Dear student, this is basically solution of exercise 2a complex number, and the exercise is basically given in SK Mapa book. And I'll start the question. The question number 6. I've already done question number 1 to 5. Z1, Z2 are complex number such that Z1 plus Z2, and Z1, Z2 are both real. That means if we take the sum of two complex number, it will be real, and if we take the product of the complex number Z1, Z2, that is also real. So prove that either Z1 and Z2 purely real and Z2 purely real, or Z1 equals to Z2. So if we see the solution of this question, first you try to think about what are the given part. So first given Z1, Z2 both are complex number, both belongs to C, such that Z1 plus Z2 this belongs to real number, and the product of these two complex number is also real number. This is given. What we have to prove? We have to prove that either Z1 and Z2 purely real, or Z1 equals to Z2. This we have to prove that. So now if we take Z1 equals to X1 plus IY1 and Z2 equals to X2 plus IY2. So then Z1 plus Z2, that will be X1 plus X2 plus Y1 plus Y2. Now since it is given that Z1 plus Z2, this number basically real, so this imaginary part will be 0. So Y1 plus Y2, this value will be 0. And here we can write Y1 equals to minus Y2. Again, if we take the product of these two complex numbers Z1, Z2, it will be X1, X2 minus Y1, Y2 plus Y1, X2 plus X1, Y2. Again, since it is given Z1, Z2, that product is real number, so that implies the imaginary part will be 0. So Y1, X2 plus X1, Y2, that value equals to 0. So this is 1. Now if we put Y2, if we replace Y2 by minus Y1, so it will be Y1 X2 minus X1 Y1. That will be 0. Since Y2 equals to minus Y1, that is by 1. So just take the common Y1, it will be X2 minus X1, this is equals to 0. That means either Y1 equals to 0 or X1 equals to X2. So this is 2. Now if we choose Y1 equals to 0, then from 1 we get y2 equals to 0? Because since y1 equals to minus y2. And in that case, y1 0 implies y2 0. So just you put y1 0 here and y2 0 here. So z1 and z2, it will be, z1 will be x1 and z2 will be x2. So, and hence in that case, z1 and z2 are purely real. Purely real. Now we have already taken the y1 equals to 0 case. Now we will take the x1 equals to x2, that case. Or when x1 equals to x2, what will happen? Then z1 basically x1 plus iy1, and z2, this is basically x2 plus iy2. So in that case, for z2 we can write, because x1 equals to x2, so this will be x1 minus iy1, because y1 equals to minus y2. So it will be z1 conjugate. So that means in that case, z1 equals to z2 conjugate. Just you take conjugate on the both sides, since z2 equals to z1 bar. So we can write z1 equals to z2 conjugate. That just you take conjugate on the both sides. So it is proved. So we have proved that here therefore either z1 and z2 are purely real, or that part we have proved here, z1 z2 are purely real, or we can say z1 equals to z2 bar. So this part is proved. What is exactly wanted in the question paper. Next is the next question, question number 7. Question number 7. This is exercise 2A, SK Mapa book, classical algebra book. Z1, question number 7. Z1, Z2 are complex numbers, such that Z1 by Z2, that quantity is real. So prove that the points representing Z1 and Z2 in the complex plane are collinear with the origin. This is also one important question in complex number. So again, we'll start the solution, and first you need to know what part exactly given and what you will do. So the given part is given Z1, Z2, both are complex number, such that the ratio Z1 by Z2, this is basically real number. What we have to prove? We have to prove that Z1 and Z2 in the complex plane are collinear with the origin. That means they lie on the same plane. Z1, Z2 and origin, these 3 points lie on the same line. Collinear, they lie on the same line. So again, if we take Z1 equals to x1 plus iy1 and Z2 equals to x2 plus iy2, then what should be the ratio Z1 by Z2? That will be x1 plus iy1 by x2 plus iy2. Next, you can write it x1 plus iy1 multiple x2 minus iy2, just to multiple denominator and numerator by x2 minus iy2, x2 plus iy2 into x2 minus iy2. So you will get x1 x2 plus y1 y2 by x2 square plus y2 square plus I y1 x2 minus x1 y2 by x2 square plus y2 square. Now if you see the given condition, this ratio is real number. So that means the imaginary part, this imaginary part will be 0. Now since Z1 by Z2, that ratio is real number, so it implies the imaginary part y1 x2 minus x1 y2 by x2 square plus y2 square, that will be 0. And from this you can write y1 x2, this is equals to x1 y2, and also you can write here y2 by y1, y2 by y1, this is equals to x2 by x1. Just we will take the ratio k, say, and this k not equals to 0 and 1. Okay. So now you will move to the, this is just I will present star marks. Now if we think about the straight line joining Z1 Z2 on joining the points Z1 and Z2 on the complex plane. That will be y minus y1 by x minus x1 equals to y1 minus y2 by x2 minus x1, x1 minus x2. Since Z1 equals to x1 y1, Z2 point equals to x2 y2, and if we think about the point Z1 and Z2, so that means x1 y1 and x2 y2. So this should be the equation of the line. This is the equation of the line. So here we can write, just using the above condition, y2 by y1 equals to x2 by x1 equals to k. So we can write it y1 minus, what is the value of y2? Just to see the ratio, this ratio. So y2 basically k y1. And if we think about this ratio, so x2 equals to k x1. Just to put this value here. So k y1 x1 minus k x1. So this value will be y1 by x1. So what we'll get? We'll get here x1 into y minus y1. This is equals to y1x minus x1 y1. So that means here we can write x1y equals to y1x. And obviously this is a straight line passing through the origin. Passing through the origin. As we know the recall, since a straight line, this is the recall, the straight line passing through the origin, origin is of the form y equals to mx. M is the slope. Basically here we write y equals to y1 by x1. So it is just y equals to mx. So that's why this is a straight line passing through the origin. So that means, or therefore, the points joining Z1 and Z2, so what is exactly you have to prove? The Z1, Z2 in the complex plane are collinear with the origin. So we can write the points Z1, Z2 in the complex plane, are collinear because they lie on the same line and passing through the origin, collinear with the origin. So this question is very, very important. Now we'll move to next important question, exercise 2a, question number 8. What is the question? The question is, Z is a complex number. Z is a variable complex number. Such that the ratio Z minus I by Z plus 1 is purely imaginary. Show that the point Z lies on the circle in the complex plane. So again we will continue the solution. The solution is basically what is exactly given. It is given that Z is a complex number, variable complex number, such that the ratio Z minus I by Z plus 1, that ratio, this is purely imaginary. So purely imaginary, what exactly mean? If Z equals to A plus IB, if it is purely imaginary, that means A equals to 0. The real part is basically 0. If a complex number real part is 0 and imaginary part is non-zero, then this complex number is called the purely imaginary complex number. So we have to prove that Z lies on the circle in the complex plane. This is our work to do. So now just let Z equals to x plus iy. Then we will calculate the ratio Z minus I by Z plus 1. So that means x plus iy minus 1 by x plus iy plus 1. So we can write it as x plus I y minus 1 by 1 plus x or x plus 1 plus iy. Just we multiply numerator and denominator by x plus I y minus 1 and x plus 1 minus iy by x plus 1 plus iy multiple x plus 1 minus iy. So what we will get? We will get Z minus I by z plus 1, this value will be x into x plus 1 plus y into y minus 1 by x plus 1 whole square plus y square, just will make in the form of a plus ib plus I x plus 1 whole square plus y square, and here y minus 1 into x plus 1 minus xy. Now it is given that z minus I by z plus 1, this is basically purely imaginary. This is purely imaginary. So the real part, this is the real part and this is the complex part. So real part of z minus I by z plus 1, that real part will be 0. So now you see the real part. So this is the real part. So that means x into x plus 1 plus y into y minus 1 by x plus 1 whole square plus y square equals to 0. So that means x square plus x plus y square minus y equals to 0. That means we can write it x plus half whole square plus y minus half whole square. This is equals to half. So which represents a circle with center at minus half half and radius equals to 1 by root 2 units. So that means this is a circle in the complex plane. That is exactly want. So this is proved because we had to prove that here z lies on the circle in the complex plane. So here we have shown that z, that means xy. So therefore we can conclude z lies on the circle in the complex plane. So generally in SSC or KVS and NVS, that kind of question has been asked. Let z be a complex number such that the ratio z minus I by z plus 1, this ratio is purely imaginary. Then which of the following is true? Option A, z lies on a circle in the complex plane. Option B, z lies in a straight line passing through the origin. Option C, z lies in a straight line not passing through the origin. And option D, z lies on an ellipse. So obviously option A will be correct option and all other option is